Hi, Mitch Winger back with another video on data analytics and machine learning. In this video, we'll dive into data visualization and how our human brain processes it. Hope you enjoy. Okay, let's get started. So as far back as 2010, MIT, in a study they did with IBM, talked to more than 3,000 business executives. They asked, where are managers who deal with data headed? And as you see, they predicted that even within a couple of years at that point in time, data visualization is going to be the analytic technique that creates the most value for organizations. And it has only grown since then. So we continue, Gartner back in 2014, developing a magic quadrant on business intelligence, data analytics, and they talked about how it's going to make hard types of analysis easy. And easy for an increasing set of users, those with a little less technical knowledge maybe, but who understand data and some of the implications and the domain areas that the data is going to be used in. So this is where that whole market is headed, and now we see it being used just about everywhere. You can actually get data visualization classes at university, whole classes on data visualization, designs of data visualizations, and so forth. So you'll see it as a whole class in a full-blown business analytics program. And we're seeing this even out at the corporate level with companies starting to actually list positions for data visualization experts, visual storytellers, and so forth. So here are a couple that I was just able to pull up by doing a search on Indeed.com, data analyst reporting and data visualization at Disney streaming services, Thermo Fisher Scientific, even a data visualization manager at Deloitte. So this brings to mind W. Edwards Deming, who was a business consultant back in the 1950s, who really revolutionized the manufacturing process. He actually pitched his processes to U.S. companies after World War II. By that point in time, they were kind of the leading economic engine on the planet, and they said no thanks. So he brought his ideas over to Japan, and slowly but surely, Japan got better and better at doing things. Anyway, one of his quotes is, "In God we trust, all others bring data." And so Japan ended up moving toward what we now know as the TQM method, total quality management approach to manufacturing and organizational processes. So what do we do with all that data? Well, that's where data visualization comes in and why it seems to be more and more important every day. So let's take a look at a grid of numbers and let's see if we can figure out how many times does the number 7 appear in here. So one thing about this review is it does take a good bit of time to find all those 7s. And you'll probably find, if you do this with your friends, that you come up with different numbers. Just depending on how much time you spend with it, how thorough you are, how well your brain processes numbers, all those things. Now how many 7s are there? So we made one simple change. We changed the color of the 7s. Now it's a lot easier to find them, so our only task now is to count them and make sure we don't count the same one twice. What about if we bold it? So that adds a little bit more even. We can underline them. So each step along the way, we're doing something that makes it easier for that 7 to jump out at us. These are called pre-attentive attributes. So we can do all kinds of things to those 7s. We can change the color, bold them, italicize them, underline them, or even add a drop shadow like you see down there at the bottom. So color, size, orientation, texture, especially if you're using black and white only publications, texture can become important there. So these things are called pre-attentive. Our brain can process these pre-attentive attributes in 250 milliseconds. So these happen before we even start thinking about what it is we're looking at. On the left, we see some of those pre-attentive attributes. Now, the other thing that we process without thinking about it very much is color. So we can encode color lots of different ways. We can use shading, etc. And again, our brain can process those color differences and notice them quickly before we even start thinking. And depending on what we want to do, we may choose the best pre-attentive attribute to focus on. Some are better for precise quantitative comparisons. Length and width give us a common baseline in two-dimensional space. If people are standing right next to each other, we can easily see which one's taller, which bar is longer than the other one or taller than the other one, etc. But if they're far apart, it's not so easy. And here are ways we can use position as a pre-attentive attribute. Order also is very powerful. We could just rearrange all the numbers and make sure all the 7s are up top. And here we can see we have one full row of 7s. So we now are starting to develop a little bit more information about this data than we had before. We're starting to turn this data into some level of information. Here we didn't even do anything to the 7s, but we grayed everything out a little bit in the background. We made it a little bit lighter so those 7s jump out at us even more than they did before. Now if we wanted to highlight a different number at this point, we could make the 5s a different color. Make them black or red or something like that. So if we have black text that we're working with and it's already bolded, well, we can't make it darker or bolder. So a lot of our data visualization tools, Tableau is probably one of the forerunners there, realize this, and they give us kind of a light gray typeface as a starting point for just about everything it does. So the number of times it did appear is 17. So we could put that in a bar chart along with the other digits and see how it looks. So we now have a little bit more information about not only the 7s, but the other numbers as well. Now we can also order them. Right now we have them ordered by the number of the digit. We could order them by frequency. So we can see here 7 comes up about the same number of times as 1. So here, if I were just looking at the bars without the labels at the end of them, I'd say, yeah, looks like 7 came up about the same number of times as 1. And they are the two closest. Now I easily find, well, what was my most common number? What was my third most common number? That might be a little tougher to do here. So just depending on what you're trying to do, you may order these differently. All right, so let's take a look at these pie charts. So pie charts are problematic in a number of ways. How would we answer the same questions? Which digit showed up most? Well, I see a blue slice that's 34. Is that 3 the same shade, or is that 1 the same shade over on the legend? Here on the right, you see you kind of have an awkward wheel of legend indicators around the perimeter of that pie. So I guess the digit 0 showed up 10 times, etc. All right, so you're going to work a lot harder to figure out the answer to any questions you have with either of these approaches than you do right here or even right there. So the idea is we want to move from data to information. How many, how much? We want to move into the why questions. How can we do something going forward? How do we decrease expenses? How can we? How did we? All right. So data visualization is terrific for how that works. But the human beings, and we're always communicating with human beings, need to be able to interpret that appropriately. So let's take a look at some other aspects of visual perception. Now you'll notice often, even when we're discussing things with no visuals support, people will say, I see, or show me. So we refer to our visual sense frequently. So this image is an object that appears to be gray on the top, white on the bottom. Now, you might be surprised if I told you that the main shade on that top piece is the exact same shade as on the bottom piece. Let's check that out. And the reason is that we perceive light to come from above. So we assume that the sun is shining on that darker gray and lighting it up a little bit, but that the white lower portion is in the shadows, so that's just a natural effect of the lighting source. Okay? So, no real shadow. This is a two-dimensional image. So we pull it back out and see that it's the exact same shade all the way down. All right, so same thing here. Now this worked a little bit better back in the days before we had a higher color accuracy in our computer screens. So how many shades do we have here? And depending on how well you discern color, you may say 2. I've got the light blue on the left, I've got the dark blue on the right. So I guess the qualifier there would be, how many shades of blue do you see? And depending on how well you see color, many people will likely say, we've got 2. We've got the light blue on the left, we've got the dark blue on the right. Now, if we move things out of the way, we could see we actually have 4 distinct shades of blue. All right, so let's take a look at this young man standing in the corner of a room. And now he's on the other side of the room. Wait a minute, what happened? Did the boy grow? Did the room shrink? So what's going on here? And if you've ever been to one of those funny house tourist trap type attractions, you probably realize that the room is actually not a standard rectangular room, but it is much deeper here, much farther back to that corner, but it's set up in such a way that when we view it from this particular angle, it has a square look to it so that we see it as a regular room and the kid is just getting bigger and smaller. All right? And this is kind of the same concept as you have here, where you can fit the Washington Monument between your fingers. There used to be a show, Kids in the Hall, where they would do that with people's heads. This picture actually reminds me of a friend of mine who always would take a picture of his wife with some kind of monument or landmark coming out the top of her head in the photo. So here's to you, Dave. Here's how they set up that room, just like we see now. In this case, it would have been the angle on the other side, the deeper angle on the other side. But if we're looking from that one end of the room, here's how it works. And the name of it is an Ames room. All right, another way we perceive distance. So let's take a look at that blue line further down the railroad tracks. So you might think that that's a longer line than the one in the front. But if we bring everything together, you can see they're the exact same distance. So the notion of perspective comes into play here. We sense that these railroad tracks are getting farther away from us. Again, even though it's a two-dimensional picture, and we do those mental gymnastics in our head. All right, so shadow also plays a role in helping us determine three-dimensionality. So do these buttons seem to be pushed in or kind of indented in, or which ones seem to be indented out? Most people would say that light typically comes from above, so let's see, the top center and bottom center ones we would think are coming out, and the other ones would be pushed in or indented. And if we rotate this all the way around, then even though it's the exact same image, our perception gets reversed. Here's another one, a crater, black and white. Or is it a crater? Looks like it might be a hill that we have to climb instead. So again, perspective, lighting, what we expect, we kind of fill in blanks. So here's one that can be a little bit unsettling, and we call it the Moiré effect. So when we've got all kinds of lines real close together like this, we might see some kind of a shimmering effect when you look at that image too intently. And that's not a comfortable feeling for some of us, and it gives some of us that feeling, at least in my case, that's real similar to when I try and read for an extended time period in a moving car. And now if we stack two of them on top of each other, it gets even worse. So think about that when you decide how to set up grid lines on your bar charts or line charts. Look at that top one. There's so many grid lines that you almost get that Moiré effect. And the grid lines are dark, real small increments. And they get in the way of us being able to actually read this chart. Do we really need to know every 50? Or would something like what we see down below work a little bit better? Yeah, we know they're getting better. We're getting a little over 200 by 7 o'clock for the blue line, all the way up above 800 by the end of the evening for the purple line. And we've grayed out those grid lines so they don't create quite so much visual clutter. So similar to that effect we have with the grid lines, if you have a bar chart with just too many bars, you get kind of that same deal. In this case, you might just want to eliminate the spaces between the bars, in which case you would have to put colors in instead. But when you have this many, you might want to rethink your approach. Another effect is called the Hermann effect, or a scintillating grid. So what happens is we move our eyes around and look at different pieces of the grid, we see what look like dark spots in the white intersections of the places we're not looking directly at. So this is a little distracting and something you might want to keep in mind if you put together a unit chart like this. Again, you might want to, instead of just having a big wide line, just make a hairline between your units. The Gestalt principle, here again, we're filling in the blanks just like we did from a perspective standpoint with the train tracks receding away from us. Here we fill in the blanks of a shape that's implied by what we see here. We fill in the shape and see that triangle. And that white triangle on a white table apparently is covering 3 full circles, right? Well, of course, there's no triangle. There are no circles. We just have those 3 Pac-Man shapes. But our brain fills in the details for us. Same thing here. We're going to fill in the blanks. We see the circle. We see the triangle. We even see that rounded rectangle outside surrounding everything. And here we can see what looks like a jumble of pickup sticks maybe. Maybe one's broken. And as we fill in letters around, we can turn it into whatever we need. Going from left to right, we'll turn that into an A. Cat, sure. Going top to bottom, we'll turn that into an H. The word the. Proximity also plays a role. That's another Gestalt principle where we fill in the details based on proximity. So if we're encoding our squares with different colors, our brain groups them together for us automatically. So if we were to say, are there more blue squares, more black squares, more orange squares, our brain sees all the blue squares lumped together. So most of us would just immediately say blue. And as we can see, we end up having the same number of each color. So again, understanding how our mind processes visual information can help us design it appropriately. So we can use this proximity. Anything that's near each other is going to appear to belong together. We adjust the space and all of a sudden we have 4 small clusters. Or next to that we have 4 rows of data. Over to the right of that we have 4 columns of data. Next, we have 4 columns of data in the lower left, but we're alternating color rows. So here we're mixing colors or rows and columns of data. And in the final one, just by using color, we can create a square inside that array of dots. Again, not a ton of shifting, just a little bit. Shifting the position, or shifting the color, or shifting both. All right? So another thing is, our brain processes information all the time, but our brain does like to work efficiently. So let's stare at that dot in the center for just a few minutes while I chat at it. So our brain wants to conserve energy, and as you stare at this, your brain starts to say, yep, it's still the same. Yep, it's still the same every few milliseconds, and it finally says, okay, I've got it. I don't have to keep processing this same picture because I know it's going to be the same the next time I refresh. So much like a computer monitor, your eyes and your optic nerve process visual information at a certain speed. All right, so we're still staring at the black dot. Now I'm going to switch to the next screen and just keep staring at that same spot. Now, is that picture in color? Sure looks like it. But as you continue to look at it, you'll see it actually is not. This is a black and white photo. But by superimposing that retained image in your brain over the black and white image, it appears in color. And we can do that same thing here. Okay, so here we're looking at the lady's nose, and we'll do the same thing here, but this time the next screen is going to be perfectly blank, and we'll see what we see. And hopefully you were able, at least for a few seconds, see that lady's image. So the idea is we've got all kinds of data in our world. The tools help us look at what has happened, what's happening now, what might happen in the future. We can test out or model different scenarios. So the main goal is to understand our world, our business, our process a little bit better. Change our behavior, make better business decisions, etc. And we ask our questions of the data to do that. So this is a process of human cognition, asking those questions, finding patterns or verifying patterns that our tools have helped us discover, drawing some meaning. So this is a creative process, visually driven. It requires those empirical and mathematical skills as well, though, because the tools are bringing those to our fingertips more and more. It absolutely requires subject matter knowledge. You need to know your industry. You need to know your business. You need to know your function. So the software helps us a lot, but the computers can't figure out what it means at this point in time. We're not there yet. How it connects to the problem. What we should do once we have that information. So data needs are changing. We're dealing with more and more different types of data all the time. And the objective is we're all used to smartphone interfaces now. We want it to become that easy to do just about anything. It's not that easy. So knowing how to work the tools to get the information in a good display is a difference maker for you. Again, we don't typically train for this visual intelligence, but it's something that you might want to work on and practice with to get better at. All right, last takeaway. So, of course, almost any of us would look at this and say, yep, this is a dashboard. It's a data visualization, no doubt about it. What about this? Would we consider this a data visualization? This is the website for the Cleveland Museum of Art. So the data is the pictures of the art they have in the gallery. All right, maybe not the kind of data you and I think about day in and day out, but what if we do this? Let's say we've got it set up so that when the user hovers over that picture, that gives them a little more information. Those of you who've used Tableau are already familiar with that. Now if we click on it, we bring up even more information. We've got the title of the piece. We've got some basic information about it. Maybe we can scroll down. So certainly, I would hope you can now think of that as a data visualization. Remember, we're trying to understand what's going on. make better choices, change our behavior, etc. Understanding how visualization plays a role is going to help us get there, hopefully for everyone. So that's it for our overview of visualization and the human brain. I hope you found the video useful. Be sure to check out the other videos available in this series.